Welcome to the Statistics Lab, and this lesson on testing for equality of two population means. When the population variances are unequal, we will use Welch's t-test. Let's begin with the question. A pharmaceutical company is testing the effectiveness of two pain relief medications, medication A and medication B, to compare their performance. Researchers measure the time it takes for each medication to provide relief to patients. For medication A, a sample of 6 patients was tested. The average relief time was 8 minutes, with a sample variance of 4 minutes. For medication B, a sample of 7 patients was tested. The average relief time was 10 minutes, with a sample variance of 9 minutes. Assume that the variances in the two populations are not equal. At a significance level of 0.05, we are tasked with testing whether there is a significant difference in the mean relief times of the two medications. Let's solve this step by step. Step 1. Collect the given data. For medication A, the sample size N1 is 6. The sample mean x1 bar is 8, and the sample variance S1 square is 4. For medication B, the sample size N2 is 7. The sample mean x2 bar is 10, and the sample variance S2 square is 9. The significance level, alpha, is 0.05. Step 2. Set up the hypotheses. Let the population mean for medication A be mu1, and for medication B be mu2. The null hypothesis states that mu1 equals mu2, or equivalently, that the difference between the means is 0. The alternative hypothesis states that mu1 is not equal to mu2, or equivalently, that the difference between the means is not 0. This is a two-tailed test. Step 3. Calculate the test statistic. The formula for the test statistic is T equals the difference in sample means divided by the square root of the sum of variances divided by their respective sample sizes. Substituting the values, we have T equals 8 minus 10 divided by the square root of 4 over 6 plus 9 over 7. Simplifying this, we get T equals negative 2 divided by 1.397, which equals negative 1.43. Step 4. Calculate the degrees of freedom. The formula for degrees of freedom is a bit complex. It is the square of the sum of variances divided by sample sizes, divided by the sum of their squared components divided by their sample sizes minus 1. Substituting the values, we get degrees of freedom equals 10.49. Since we use the integer portion, degrees of freedom is 10. Step 5. Calculate the p-value. For a two-tailed test, the p-value can be found using software or a calculator. Using Excel, the formula is t.dist.2t of 1.43, 10. Here, 1.43 is the absolute value of the test statistic and 10 is the degree of freedom. This gives a p-value of 0.1832. Step 6. Make the conclusion. If the p-value is less than alpha, we reject the null hypothesis. If the p-value is greater than alpha, we accept the null hypothesis. Here, the p-value of 0.1832 is greater than the significance level of 0.05. Therefore, we accept the null hypothesis. In conclusion, there is no significant difference in the mean relief times of the two medications. At a 5% significance level, we do not have enough statistical evidence to conclude that there is a difference in the mean relief times based on the given sample data. Thank you for watching. Please like and subscribe for more statistics content.